Welcome to my YouTube channel. Please subscribe, share, download, and comment. Once more, you are welcome.
Greetings, my distinguished members. I wish to greet you at this hour, believing that you are all well. Welcome to my today's video. And to start with, today I want us to develop a circuit that we will use it to display some characters on an LCD, or rather a liquid crystal display. And remember, we are doing all this from Tinkercad. However, the same procedure that we are following to do the connection in Tinkercad will also apply in a scenario where you are doing the physical connection. So either doing it on Tinkercad or doing it in a physical scenario, the procedure is the same. The connections are just the same. If you follow the steps well, you will achieve the same thing in physical scenario as you have achieved in Tinkercad. So let us get started, believing that you're already in your Tinkercad account and you have already created a new circuit and being redirected to the working space. So as usual, we make sure that your circuit has a title. It is essential. However, it is not mandatory. If you choose not to, there's no problem. But I said having a title for your circuit, it gives your system or your circuit a better glance at fire for anyone who intends to watch what you have just constructed. So it's good to have the title. So let's get started, and we are going to start by getting our components on our working ground. So we can start by pulling our components. So we have not a C, but we have our microcontroller. We also need to have a breadboard for the connection. So that is our breadboard. We also need to have this potentiometer. The potentiometer will be used for controlling the contrast of our LCD. So we also need to have a resistor for controlling the backlight, or the LED that provides light at the back of the display. We also need to have our LCD, and in this case we are using a 16:2 LCD. This is a LCD with 16 columns and 2 rows. So we have our LCD there. And for those maybe who are not familiar with the LCD consists of a number of pins ranging from the ground all the way to the backlight cupboard. So in between we have ground, we have the power. This is the pin that connect to the our supply, our voltage supply. It could be 5 volts or 3.3 volts or another specification depending on the LCD that you are using. Then the next one is the contrast. This is the pin that is connected to our potentiometer for the controlling of the brightness of our LCD. We also have the register select pin. This pin is used to specify the mode under which we are operating our LCD. Our LCD can operate in data mode or in command mode. In any of the two, we activate it by setting the logics, either setting it high or low. For instance, we want to operate this one under command mode. We connect that pin to ground. If we want to operate it under data mode, we connect it to the to our Arduino. So, and I'm sure maybe some are not conversant with these two modes. If we talk of the data mode, we simply mean that if we have configured our LCD to be under data mode, anything that comes to the LCD will interpret it as a data character, and therefore it will display it. And if you operate it under command mode, we simply mean that whatever comes to the LCD, whatever is sent to the LCD by the Arduino, the LCD will interpret it as instructions, and therefore it will operate, or rather it will respond or do what that instructions demands it to do. So that is all about our RS, or rather the register select pin. The next pin we have the read or write pin. This is used to specify whether we are doing the writing or the reading of whatever is in the LCD. So if you want to write it to the LCD, that is, you want to bring data to the LCD, you connect that pin to ground or to logic 0. You want to read what is on the screen, you connect it to a certain power, 5 volts, that is logic 1, and that one is connected to the Arduino. Then the next pin is the enable pin. This enable pin essentially is used for the activation of the LCD. It is also used to notify this LCD in event of data being transferred to the LCD. In other words, it alerts or rather creates awareness to the LCD that some data has been transferred to the data bus, and therefore it is mandated to check on that data and respond to the same appropriately. From there we have the data bus from data bus 0 all the way to data bus 7. So this data bus, they are used for the data transmission from the LCD, from our controller here to the LCD. So depending on the data that we tend to transmit from the controller to our LCD, we can use any of these pins. For instance, if our data is an 8-bit data, we'll use all of these pins. But if our data is a 4-bit, we are going to use the last 4. That is from data bus pin number 4 all the way to data bus pin number 7. We cannot use data bus 0 to data bus 3 if we are transmitting data in 4-bit. So these 4 pins, the data bus pins, are preserved for, or rather they are only used when we are transmitting 8-bit data. So then we have the last 2 pins here. We have the backlight anode and the backlight cathode. These 2 pins are used to control the light, the backlight. We have an LED at the back of this screen that enables us to see the characters that are displayed here. So the level of brightness of that LCD is controlled using these two pins. So I think we are good to go now. I want us to start doing the connection, and I prefer starting by doing the powering. I want to connect my breadboard with some power, so I'll start by connecting the ground. Let me connect the ground. That is my ground. I can change the color to black. I can also do some. I can bring the voltage, that is the 5 volts, into my breadboard to make it a bit decent. is it. That needs the color. Sorry, that should be black. I need to change this one to red to adhere to the right color coding. So I've done with the powering. The next step is to do the connections for the pins that I have. I'll start by doing the powering of the LCD. So I can just push this my LCD up a bit. So I can start by connecting the ground. So yes, let's start by the power. Here's the positive terminal. So I can connect it there. I'm done with that. I have ground. Ground is that. Then this one I'll make it black. Then I have the next pin is the contrast. This contrast, if you look at this one, these are the terminal 1, terminal 2. These are used for the powering. Then the middle leg is the one that is connected to our contrast pin. So I can connect it there and make it a bit. Let me pull it down and push it up. And change this color to green maybe. Green. Then I connect the other leaves to the power. I can connect this one to the positive terminal. I connected the 5 volt. Then I change the color to red so that it may be visible and distinguishable from the other pin. So that is the negative terminal. I'm done with that. So this one I'll use it to control the brightness, the contrast of this LCD. Now the next one we are going to that is the register select pin. So we are going to connect it to pin number 2, but you can use another pin of your choice as long as the pin that you use, you make sure it is the one that is reflecting in the code. So pin number 2 can change its color maybe to which color? Green, not green, let me use blue. The next pin is which pin? Read and write. Now remember I've said that this pin is used for specifying whether we are writing or reading data from the LCD. In our case we are there to display. In other words, we are bringing data to our LCD. So bring that to LCD means that we are waiting on it. So we are going to connect it to ground. Supposing we were to read data from it, we would have connected to our Arduino here. So let me make that one black. First disconnect the ground. Then the next pin is a enable pin, which I've said it is for activation of our LCD. It specifies, or rather it tells all alerts the LCD of presence of data in the database, and the LCD responds accordingly. So that is our enable pin. Then the other pins are from D0 to DB3. Because in my case I want to use 4 bits. The data string will be of 4 bits, so I will not use those pins. I can leave them unconnected, or I terminate them on the ground. I can terminate them on the ground or leave them just unconnected. So but let me connect them to the ground. So I've connected the 4 of them to the ground. So the remaining pin is DB4 all the way to DB7. So those are the that I'll be using to transmit, or rather transfer data from my microcontroller to the LCD. So I'll connect that pin data bus 4 to pin number 4 of my Arduino. I also need to change that color, and I can use that. I proceed the 5th pin, one connected to pin number digital pin number 5 of my Arduino. Change the color to purple. I connect the other one to pin number 6 of my Arduino. I prefer connecting them that way, in that sequence, for consistency and also to make my work neat. I can use that color. Then I have my last pin, my last data bus pin, which is pin number 7. I'm connecting it to pin number 7 of my Arduino. Pin number 7. Pin number 7. Connect that one, maybe green. So those are my pins. Then I have my last 2 pins here. In this case, we have to connect a resistor between our anode here and the power. This one will be used for the control of controlling the current that is going to the backlight LED. So you also need to change its value. The resistance value for this can range from 153 ohms upwards. So the limit in the upper side will be determined by you depending on the level of brightness that you want in your LCD. So let me use maybe 330. That is okay with me. Then I change the units here to ohms. Then the last pin I connect it to the ground. That is the cathode, the backlight cathode. I connect it to the ground. So I'm done with the connection. So this is the connection that I have. Now the next thing, we have connected it in the right way. All the pins are being terminated well. So the next part will involve developing the code, and I intend to do that in the next video. So I'm hoping to see you back in the next video, where we'll be developing the code that we'll use to send a string, rather some words to this display from our microcontroller. So bye bye for now. Stay tuned for the next part of this video. So thank you so much. Stay blessed.
Thank you for watching our video. Stay tuned to get part 2 of our video. Please remember to like, subscribe, and leave a comment. Also remember to click the bell to be notified